All right, so let's continue on our talk with factoring x squared plus bx plus c with this second video. I have 3 problems to take a look at. All right, so the next one here says, how does multiplying binomials in 2 variables relate to factoring trinomials? Right, so again, my number one message to you is this is no big deal. No big deal. You're just adding another variable. Who cares, right? You're still going to multiply out the same way, right? So this x goes to the x and the 4y. So this will be x squared. When you multiply x with 4y, it's just 4xy. I put it in alphabetical order, right? You could do 4yx, it doesn't matter. And then the 2y goes to both parts. Again, when you do 2y times x, you get 2xy. And when you do 2y times 4y, now 2 times 4 is 8, and y times y will be y squared. And you just combine the middle terms like you normally do because they both have xy, x to the first, y to the first. So that's x squared plus 6xy plus 8y squared. Again, if one sign's positive, one sign's negative, again, no big deal still. X gets multiplied to both parts, x squared plus 5xy. Make sure you multiply next the negative 3y. So that's going to make it a, not equals, sorry. Not equals. That's going to make this a negative 3xy. And negative 3 times negative 3y times positive 5y is negative 15y squared. Again, you combine the middle terms. Even though they're different signs, they still have the same variables to the same exponents. That's x squared. 5 minus 3 is positive 2xy's. And then the minus 15y squared just comes at the end. And again, down here, same thing. The double negatives, who cares? X to both parts. X squared minus 9xy. Negative 7y to both parts. Negative 7xy. And then a negative times the negative is a positive 63. And then y times y is y squared. Combine your middle terms. X squared. Negative 9 and negative 7 is negative 16xy. And then the positive 63y squared comes. So again, it is no big deal. You are still, as it says, you are still looking for, in this formula, you're still looking for a factor pair of C that has a sum of B. No big deal at all. Don't let a second variable throw you for a loop. It shouldn't. It really shouldn't. Okay, so let's take a look at the next example here. So what is the factored form of x squared plus 10xy plus 24y squared? Okay, so again, if I use my x, first of all, this is x squared. And again, if you want to put plus bxy plus cy squared, it's okay. Whatever. The y's don't matter. You could just put x squared plus bx plus c. It doesn't matter, right? And just make sure you throw a y in the second spots in the parentheses. Here's your x method. You're looking for the factors of positive 24 that add to get positive 10. So we're looking for the factors of positive 24 that have a sum of positive 10. So if I start with 1 and 24, right, I want to make a positive 10. They're going to be the same sign. So 1 and 24 is 25. So positive 1 plus 24 is 25. So not that. We can do 2 and 12. Positive 2 plus 12 is positive 14. It's not that. Now notice here that if you were to subtract, like say it was like positive, say it was if it was negative 2. All right, watch this. Say if it was negative 2 times positive 12. Well, negative 2 plus 12, that is positive 10, so that would work. However, here, negative 2 times positive 12 is negative 24. That doesn't match that sign. So understand that when you're doing these, determining the signs, you have to make sure your two numbers still multiply to get you the correct sign and add to get you the correct sign. So this would not be right. Okay, that was just little side notes. Sorry if that confused you. Okay, let's do 3 and 8. So if we add 3 and 8, positive 3 plus 8 is positive 11. That's not right. 4 and 6. If we do positive 4 plus positive 6, you do get positive 10. There you go. So our numbers are 4 and 6. So we want to do x plus 4, right? Positive 4, positive 6. X plus 4, but you got to throw in that y, and x plus 6, but you got to throw in that y. And there's your factored form for this. So again, don't let that second variable throw you for a loop. It's not that big a deal. Okay, and last but not least, Benjamin is designing a new house. The bedroom closet will have one wall that contains a closet system using 3 different sized storage units. The number and amount, the number and amount of wall space needed for each storage unit is shown. What are the dimensions of the largest amount of wall needed that will be needed? Let's say that. Okay, so notice here that we need 13 of these small storage units, 1 of these big storage units, and 12 of these medium small. This x by x has an area of x squared. This 1 by 1 has an area of 1, and this 1 by x has an area of x. This is just the x squared, this is the bx, and this is the c terms. That's all we're doing here. Okay? Now, we need 1 of these, we need 12 of these, and we need 35 of those. So if we take these 3 expressions and combine them to find the total area, that's going to be x squared plus 12x plus 35. This is our x squared plus bx plus c. And now we need to solve this to see what the dimensions of this must be, because once we align all of these units in here, right, and again, I'm not, if I do it like algebra tile E, right, once I align these, you might have this square here, you're going to have 12 little squares, and then all the rectangles, okay, and again, but we want to know what are the dimensions going to be of that closet space, right? That's what we're trying to do here. So that's what we're going to do when we factor this, right? So here is my x, positive c, positive 35, a positive b, 12. So we're looking for the factors of positive 35 that have a sum of positive 12. So everything's going to be positive. So 1 times 35, that's 36. Nope. 2 does not go into 35, 3 does not go into 35, 4 does not go into 35. And again, how do I know that? How do I know 35 is not divisible by 2? Because I get a decimal, 17.5. If you get a decimal, you can't use that factor pair. It has to be whole numbers only. So the next one is 5 and 7, and lo and behold, 5 plus 7 is 12. There you go. Your numbers are 5 and 7. So positive 5 and positive 7. So your dimensions or your factors are x plus 5 and x plus 7, which are going to be your dimensions. Okay, and I think I said 12 here. There needs to be 35 little squares. So I'm sorry, again. 35 little squares. So this would be, again, this would be like having 7 rectangles here and 5 rectangles there. So this would be dimensions of x plus 5 feet. And I don't know why. Oh, they're in feet because here. So x plus 5 feet, all right, by x plus 7 feet. And that would be the dimensions. Okay, so I hope this video made sense to you. We're doing a lot of factoring in the next several lessons. Big important skill, needed in Topic 8 and needed in Algebra 2. Your Algebra 2 teachers will love you if you can remember how to factor from this class. So hopefully this video helps. All right, thanks for watching.